Hello and welcome. My name's Ian Lowry and this is an introduction to and a demonstration of active anchors.
Most anchors work reasonably well on ground most suited to their given design, but few work well on a broad range of seabeds. None, apart from active anchors, are releasable without the use of a sacrificial component or reverse release buoy. Most people's first impression of an active anchor is simply to see a sand anchor. The reality is, active anchors also perform exceptionally well on hard rock, gravel, and in soft mud. They are a highly effective tool that can easily be retrieved and reset even in the most difficult of circumstances. The enormous benefit of this design is as much a product of discovery as deliberate intent. Nonetheless, the not-so-obvious attributes are supported by basic physical principles that dramatically improve performance. This truly revolutionary design is fully releasable and immediately reusable. The active anchor design employs a spring and pivot action to set into the seabed and take hold. The mechanism works like pushing a shovel into the ground. Using your foot to apply pressure to the top of the shovel blade, if it gets stuck, you rock the handle back and forth to both get the blade past hard objects and to move dirt away from the upper part of the blade. The same action is created by an active anchor automatically due to its spring linkage and the rocking action of a boat pulling on the anchor. In simple terms, water provides the force and the U-shaped shank spring provides the rocking action to the flukes. The one feature that makes the design so revolutionary is the toggle action release mechanism, both because it can be set at multiple pressures, making the release function safe and easy to use, and for the ability to simply turn the release off to a fully locked hurricane setting. Watching one go into the ground is like watching an animal looking to get a bite in. As soon as an active anchor hits the ground, it goes straight in or crabs along the rock until it finds a crevice to slip into. This claw-type action is a deliberate design feature, as are all the attributes of the fluke shape. It may look like it was created with a superhero in mind, yet all attributes of the fluke are designed for stopping power, not for the way they look. The most important design feature of an active anchor is that the centre of mass is near the fluke tips. All the weight at the back of a standard Danforth anchor prevents them from rising up at the rear, so the tip of the flukes often can't get a hold to bite in. With an active anchor, when the shank is pulled forward, the rear of the flukes rise, driving the tips into the ground. As a result, the bulk of the surface area of the flukes goes into the ground immediately, and the maximum holding power of the anchor is achieved quickly. This feature has additional benefits. Firstly, it makes the anchor very stable on its fluke tips, unlike most sand anchors that never get into the seabed because they constantly roll over and can't dig in. Secondly, in the water, the active flukes pitch down as the anchor drops to the ocean floor, making them appear to swim away from the boat towards the seabed. It's great to watch, but has the added benefit of moving the anchor away from the drop point so the rope and chain don't get tangled around the anchor as it hits the sea floor. The tapered outer edges of the active anchors create a highly effective cutting edge that drives into most seabeds with ease. This keeps any ploughing action to an absolute minimum and leaves the ground largely undisturbed. This feature reduces the environmental impact of anchoring in weed beds and greatly increases the holding capacity of a given seabed. For reference, there are areas in Australian waterways that preclude anchoring by boats to stop the spread of invasive weed species. The cutting edges also make removal from the ground easy, as the flukes simply slip out backwards without disturbing the ground. In addition, as the anchor is pulled in different directions by a boat, the flukes cut through the ground side on to maintain hold. The active release function has 5 settings from light to lock. However, what's not immediately obvious is that the light setting does not greatly reduce the holding power of the anchor in sand, mud and shale. This is because the flukes are held in a relatively static position in soft ground, which pushes the flukes back toward the rear of the anchor, keeping the spring links in their normal anchoring position. The release function is most easily triggered on rocky ground, where the fluke tips are the only part of the anchor in a crevice or ledge. More than likely, rock is where the ability to release an anchor is needed the most. As most anchoring is done in bays, rivers or estuarine settings, anchor drag is a real danger because there's often other boats in proximity and less room between obstacles. The rope angle of an active anchor can be increased by up to 15 degrees more than any other anchor tested without dislodging, and has twice the stopping power of a given weight in soft silt and mud due to the parachute effect created by the spring. This test shows the difference between a standard 3 kilo Danforth and a much smaller 1 kilo active anchor. For reference, the following chart produced by SV Panopi shows the marked reduction in performance of a range of anchors in soft mud. It's obvious to see from the chart how poorly most anchors perform in soft mud. The best use of the slide ring is when anchoring in areas where there are old ropes, underwater cables or tree roots. This is because if you do snag a rope or cable, it will tend to slide down the flukes toward the pivot point of the anchor. It can then be difficult to trigger the release mechanism as you can't apply enough leverage to the flukes. If there is a possibility of this happening, have the rope attached directly to the ring so it can slide down the shank. If you do get caught up, let the anchor drop to the seabed and drive backward over the anchor, making sure the rope is slack. As you go over the drag point, gently lift the anchor rope up when you feel the ring is next to the release collar. This will allow the fluke tips to pitch down and the offending rope or cable can fall away. Deepwater anchoring can be made easier and simpler with the use of a float with a ring attached. If the anchor rod is run through a steel ring connected to a buoy, as you drive away from the anchor point at speed, the boat can do the work of both triggering the release and lifting the active anchor to the surface. This makes it easy to retrieve the anchor and coil the rope into the anchor well or a bucket. When using a float retrieval buoy, always tie off the rope to the bow of the boat when lifting the anchor, so that if for any reason the anchor does not release, the boat will still be bow first into a prevailing swell.
If you've got any questions, please don't hesitate to get in touch and send us an email to info@activeanchors.com.au. Thanks for your time.